Kia ora, Year 10. This is the second video going over some of the old exam from back in 2017. It's just really good summary revision of lots of different skills. This video also is unistructural skills. Please make sure you have your maths book out with you and your calculator and your pen, and you work through the questions with me as I go. Okay, so we're going to start off on question 6 and probably go through to about question 14. This will be about 14 or 15 minutes long. So the first question is a straightforward increase by a percentage one. We have to increase this amount by 17%. So we know that to increase by a percentage, we need to have 100% plus 17. And that gives me, just change stylus, that gives me 117%. And we turn that into a decimal, which is 1.17. Now, most of you by now will probably be doing that in your heads. That's fine. That's just a quick bit of revision. If you're not good on that skill, make sure you go to Dr. Frost and do a bunch of them. So the final answer here will be 248 times 1.17, which gives us $290.16. The next question is an algebra one, really, really important skill, which is substituting into an expression. So we're given this expression, 6p minus 5q, and we're told to evaluate it if p is 11 and q equals 4. So here's how we do this one. We've got 6 times p minus 5 times q. So we replace the p with 11, and we pop back in our times sign because we're back to working with numbers. And then we do the same thing for the q. So we get 66 minus 20, which gives me, well, I can write that out if I want to, but it's fine just to do that on your calculator and just write the final answer, or preferably in your head. So that gives us 46. Right, the next two questions are pretty straightforward. That's why they're unistructural. We're just asked to take a pattern and to write the next 3 terms in it. And both of these two here are linear patterns, right? The increase from one term to the next is not changing. So we can see with this one that it's going up in 4s. So the next 3 terms are 23, 27, and 31. Now, for most of you watching this, I want you also to think about how you could write the rule for that pattern and how you could graph the rule for that pattern. And the same thing for the next one. So just have a think about that, and you might want to do that in your book. The next 3 terms in this pattern will be, well, let's see, it's going down in 2, so minus 2, so it's linear. We need to keep going down in 2s, so we get -1, -3, and -5. And the same questions for this one. Think about how you could write the rule, and think about how you could graph the rule. Now we're on to some algebra. So to simplify the following, if we've got 3x times 5x, we're going to multiply the numbers together. We get 15, and then x times x will give me x squared, right? Remember that 3x times 5x just means 3 times x times 5 times x. So the order that I'm doing stuff in doesn't matter. Okay, sorry about the coughing. I'm not going to be at school tomorrow. The next one is very similar, except that we've got x squared and x cubed. So with this one, we again multiply the numbers. We get 28, and then x squared times x cubed will give me x to the power of 5. And that's because x squared is x times x, and then x cubed is x times x times x. So that's where the x to the 5 comes from. Most of you at this point are going, look, the base is the same, so all I have to do is add the powers. The same idea in the next one. We've got 21b squared over 7b to the power of 5. So that gives me 3 over b cubed. I'm going to write that one out the long way over here as well. So we've got 21 times b divided by 7 times b times b times b times b times b. Simplifying, I get 3 here, and I end up with b times b times b here. Okay, so remember, we think about that as where are the numbers heavier, where are the b's heavier, and they're heavier in the denominator. So that's why we end up with b cubed down here. Now this last one tricks people often, but if you go slowly, it's not that hard. So the square root of 49p to the 12 means something times the same something has to get me back to 49p to the power of 12. Well, the number part of that's pretty obvious. It's going to be 7, right? 7 sevens are 49. But here, this is going to be p to the power of 6, right? Because when we multiply algebraic expressions, we add the powers. And you can see that if we are going backwards, we want p to the power of something times p to the power of something. Those two powers have got to add to give me 12. Hey guys, I'm really sorry about the coughing right through this video. Not very nice. Now we're on to the last few, which are some algebra, then some trig and Pythagoras, and some graph drawing. So we're going to expand these. We've done lots of this year. So this is 4x times 5, which gives me 20x. And then we're going to go 4x times 2x is 8x squared. It's going to be 20x, take away 8x squared. In this one here, we're multiplying all of this times 3. So 3 times 3x gives me 9x. Right? 3 times 2y gives me, take away 6y. And then 3 6s are 18. In this last one, we're multiplying all of the terms in here by x. So x times x is x squared. And then we've got plus 2pyx for the next one. Now we're working backwards and we're doing some factorising. Fully factorise the following means take out the highest common factor. We always look at the numbers and the variables. Highest common factor in the numbers here is 8. And we don't have a t here, so that's the highest common factor. 8 watts get me 8t, 8 times t. 8 watts get me 72, 8 nines. In this next one, we do have a common factor in the numbers and also in the variables. So the highest common factor of 12 and 18 is 6, and the highest common factor of the variables will be t. So we have 6t times 2t minus 3. Okay, so now we've got 3 questions that have got triangles in them, and I would really like you guys to write these down into your book. So copy the triangle down and then attempt these 3 questions on your own before I go through them. I feel like we've done lots of these, but I'd like you to make sure that you practice them on your own one more time. So do that now, pause the video, and then come back and I'll go through them. Okay, the first one here is Pythagoras, right? It's Pythagoras because I've got 2 sides and I have to find a third side, and I've got a right angle triangle. So we have 7 squared plus 12 squared equals a squared. I would have called it x squared, but there you go. That gives me 49 plus 144 is equal to a squared. So what's 49 plus 144? That's 193. So a is equal to the square root of 193, and that equals 13.9 centimetres going to 1 decimal place. In the next one, we have a trig question because we have an angle and we have one side given and we have to find the other one. So labelling to start with, this side here, the long side here is the hypotenuse, and B is the adjacent side. So we think about whether it's sine, cos, or tan. Which 2 sides are we linking? Well, we're linking A and H, so it's cos. So cos of 35 degrees is equal to B over 5. Multiplying through, I get 5 cos of 35 is equal to B, and I chuck that into my calculator, and I get B is equal to 4.09576, which we don't want, because that's a silly answer. We want to round it sensibly. So B is equal to 4.1 millimetres. Okay. So you can see that these are unistructural questions. So we've got an easy one here where we've got the unknown thing is in the numerator. Okay, so there's just a couple of steps of working. Sorry, this is a little bit squished. I'll make it bigger. Right, this last one is one where we've got trigonometry and we're looking for the angle. So we start again by labelling. We've got the opposite side here and the hypotenuse here. That means that we're working with sine. So sine of C is equal to 7 over 13. We need to undo the sine function using the inverse sine. So we're asking what angle will give me a sine of 7 over 13. And on the calculator, this is what we do, right? Remember that this button will be one of your second level yellow buttons, so you're probably going to be looking for the shift button. But you should, if you don't know how to do that, ask the person sitting next to you where it is. Most of you know that already. Okay, and that gives me an answer of C is equal to 32.6 degrees, rounding to 1 decimal place. Just got time for the last few here, so we'll get down to questions. Where are we? Oh, we're nearly finished. We're on to question 14. So question 14 is just a little bit of work on how to draw linear graphs. And you'll see that we've got 3 graphs to draw. And the first one is in the format that we're used to, and the second need a little bit of thinking. So whenever we draw a graph, we like it if it's written in the form y equals mx plus c. We start by taking the y-intercept value and plotting that. So for y equals 3x minus 5, we know the y-intercept is 0, negative 5. So we put a point here, and then we know the gradient is 3. We can think of that as going out 1 and up 3, out 1 and up 3, out 1, up 3, out 1, up 3. And then we take our snapper card or our ruler and we join them up like this. Let's see if I can do it without coughing. There we go. So that's the first one, and it would be a good thing it says label each graph clearly, so don't forget to do that. That's line A. Now if we look at the next one, it's not quite as nice, but it's not bad. For some stupid reason, the y-intercept has been written first. We can rearrange that very easily. It's the same as y equals negative 2x plus 7. So again, we start with drawing the y-intercept at 7. Here it is here. And the gradient is negative 2. So this time we go out 1, and then we go down 2, out 1, down 2, out 1, down 2. You don't have to do that many points. It just makes it easier to get it accurate if you're doing it on a laptop. So here's my second line, and I'm going to label that line B. Now the third one is one that we looked at in class last week, and you can do it 2 ways. You can either rearrange it to y equals mx plus c, or you can do the method of finding values that are on the line. That's what I'm going to do first. So let's have an x value and a y value. So if we make x equals 0, when x is 0, we have 0 plus 2y equals negative 12. So for it to be on the line, we have to have y equals negative 6. So when x is 0, y is negative 6. Now I'm going to do the same thing, but I'm going to say what do we have to have when y is 0? Well, that will mean that we have 3x plus 2 zeros is 0 is negative 12. So x must be negative 4. We can plot those 2 points. Right? So you don't have to do all of this working, but when you're starting out with these, it's a nice way to see what's going on. So x is negative 4, y is 0 is here, and when x is 0, y is negative 6 is here. Now we take our ruler and we join those 2 points up. So that's my favourite method for ones like that, but I'm going to show you how to rearrange it because I've got a minute left. Oh, we're not going to get to question 15 in this video, guys, so forget about those. So what do we have? Well, we had 3x plus 2y equals negative 12. 2y is equal to negative 3x minus 12, right? I'm subtracting 3x from both sides of the equation. Now I'm going to divide both sides through by 2, and I'll get y equals negative 3 over 2x minus 6. And if you look at what we've drawn, that is exactly what we've drawn, right? You can see my y-intercept here, and you can see my gradient as well, that here I'm going out 2. Let's just get rid of some of this stuff here and some of those other lines. So you can see that if I start here and I go out 2 there, and then down there 3, we've got exactly the same thing. We don't mind how you do those, but I'd like you to, most of you, to have both of those 2 methods mastered while you're still in year 10. Thanks very much for watching. I will do some more later on if I'm feeling okay. And you're going to be watching this in class tomorrow because I'm going to be at home sick. Thanks very much.